And this is actually something I forgot to mention to you guys in SI, so I'm glad you brought that up. Would it be the same for Cl2? Yes, I believe it would be the same for all halogenations. I know I2 has some weird exception in the reaction mechanism, but it comes to the same final product. You don't really need to know that, but it's just something weird that I remember. So, no, would there be any other polysubstitution that you need to know of? Only in the alkylation. So just know that alkylation is really the only one that does polysubstitutions, besides NH2 plus Br2. Make sense? And then at the end of the textbook, they introduced a new set of reactions that added halides to alkyl groups on the benzene. No, I don't think we're going to cover that. I don't think he ever does that in this class. We're going to go over something sort of kind of similar, but it's not going to be an electrophilic aromatic substitution. It's just going to be a different kind of reaction. Okay, so does anyone want to go over any other chapter 14 questions? I'm glad it makes more sense. Or, excuse me, chapter 15 questions. If not, we can go to chapter 16. It's just whatever you guys want. I'll give it a second. Can we look at a few more reactions for 15? Yes, so I'll show you a couple good questions that'll probably show up on the exam. Okay, this is a good one. So, which of the following molecules can be a reactant for Friedel-Crafts, right? And I chose this one because it has some of the naming stuff that we talked about. So, does anybody know what an aniline is? So one person said they think it's a benzene with an NH2. Do you guys agree? I do. So this is going to be an aniline. And another, there's a less common name for this, but I'm not going to bother giving it to you because it's not important. Okay, so all the other ones pretty much are with, like, the technical name that's kind of obvious. So nitrobenzene, what group is that going to be? So, okay. So nitro is always going to be our NO2 group. So that's going to be nitro. benzene. And then chlorobenzene, just be with the chlorine, bromobenzene, bromine, and then para-bromonitrobenzene. So let's draw that up here. Bromonitrobenzene. So, if we're looking for something that can react with Friedel-Crafts, we're looking for anything that is not a strong deactivator and that is not NH2. So, of these options, which one can work? Oh, wow, I am a dunce. This doesn't say chlorobenzene. It says chloroethene. So, an ethene would be this. Wait, what the heck am I doing? It would be like this. Sorry, I used up apparently all of my brain and SI today. That's my bad. But yes, you guys were correct. The only one that makes sense to work is D, because it is the only one that doesn't have a strong deactivator, because this is a strong deactivator, this is a strong deactivator, and NH2 also won't work. And the reason C will not work is because this is an electrophilic aromatic substitution. This is not aromatic, so it cannot work. So D is the only one that works because this is a weak deactivator. Any questions on this one? No? Okay. So let's do this one. This one is like my favorite question from chapter 15. Because it's always on the exam and people always get it wrong. So, the thing you need to pay attention to is which one will happen in greater than 50% yield. That is important. So, in the first one, we have NH2, and what kind of reaction is this? Alkylation, cool. So can Friedel-Crafts alkylation happen with an NH2? No, so this is no reaction. Cool. Also, I don't want you to look at the answer. So we know that this is automatically out. So NH2 plus alkylation, again, in this second one, can this happen? No. So again, we have a no reaction. Cool, so we know that it's not A, it's not B, and it's not D. And so now we have a regular old benzene ring with an alkylation. Can that happen? Yes, it definitely can, but let's draw this out. We have 1, 2, 3 carbon chain. 1, 2, 3 carbons. If we make our electrophile, it will look like this, right? And the answer given here, sorry, my screen is twitching. I don't know why it's doing that. The final product shows this added to it. Is this reaction going to proceed as written? Someone said no, why not? Because of rearrangements, exactly. So we are going to do a hydride shift. We are going to have this carbocation, and instead of this product, we will actually make this product. So while this product is technically possible, they're asking for higher than 50% yield. This will not happen. This will be our product, our major product. So our answer is E, none of the above. And I'll zoom out. Does this question make sense? We're all going to get it right if it shows up on the exam, right? Good. Okay, perfect. So let's do like one more. This is a really good one because it always shows up on the exam as well. Or something in this variation, right? So we are going to say this is ring A and this is ring B, right? And here we have a Friedel-Crafts alkylation happening again. And it's asking us for which of the following will be the substantial or major product, right? And so what we have to look at is which of these rings we can actually add our group to, right? And it's kind of weird because it's two aromatic rings on the same molecule, and only one of them will be able to react. And the reason is this ring is attached to a carbonyl, while this ring is attached to an NH, right? So between ring A and B, which one do you think will be active? B, exactly. So ring A, since it's attached to this deactivator, will not work towards Friedel-Crafts, but ring B will. So we have to look for the answer choice that adds to ring B, and more specifically, since that is an activator, where does it direct? Orthopara or meta? What do you guys think? Is that going to be orthopara or meta? Orthopara, yes. So I'm going to write OP, there, stop. So it has to be to one of those three positions. Number 1 is out because it added to the wrong ring. Number 2 is out because it added to the wrong ring. Same with 3. These are all out for the same reason. And so now we have to choose between the two of these. This one added meta, this one added para. So the correct answer would be E. And then Andrew asked about like why this would work, because NH2, NHR, or NR2 would all disallow benzene from reacting. While that's true, we can think of it as like two completely separate systems, right? So while this ring does have a deactivator on it, this ring has an activator. And we know NH2 doesn't work, but since this has a carbonyl, this is an amide, it will actually be able to proceed because it won't be as strong of a base. And additionally, it will be a donating group, not a withdrawing group. So if it's attached kind of in this orientation where the NH is attached to the ring and not this orientation where the carbonyl is attached to the ring, it will work for Friedel-Crafts. So yeah, pretty much it's only NH2, and if it was added, if it was like this. That's so ugly, but I'm going to not pay attention to it. So if it was like this, it wouldn't work. You are welcome. Okay. So if we keep scrolling. We kind of already did this one, but it usually shows up on the exam. So what do you guys think the answer for this would be? All of this, by the way, is just saying alkylation. So one person said A. So let's look at this. If we had this intermediate, we know that we want to do a rearrangement and we want to do a ring expansion. So we would get a 5-membered ring. There's no way to get a 6-membered ring. That's garbage. There's no way for it to add like that because we never talked about that in chapter 15. Goodbye. Why would it be adding 2 completely different groups? That's dumb. Now we're left between keeping it the same or doing a ring expansion. We know that we're always going to do a ring expansion in order to make it more favorable. So A will be the correct answer. Any question? Okay. So I know you guys said you wanted to do chapter 16 as well. So do you want to do a little bit more practice on 15 or just switch gears and go into chapter 16? Let me know. Okay, so someone said chapter 16. Is that cool with everyone? Is that what everyone wants to do? Just a yes or a no. If no one says anything. Okay, cool. So this is what we got through in SI today. We just did the gem diol reaction. Do you guys want to redo this reaction or do you want to move on to the next one? Either is fine with me, just let me know. Move on? Yes, we can. Okay, so the next reaction on the list is the acetal ketol formation. So it's going to actually be very similar to gem diol. So it's going to be very similar to the gem diol reaction. Let's do the ketone version first. So if we react a ketone with an alcohol, any alcohol, so I'll put an R group here, and an acid or a base, we will get 2 different answers. So first we're going to do the acid, and then we will do the base example. So if we have an acid catalyst, the first step is going to be that the electrophile will become more electrophilic by protonating itself. So we get plus charge here. And now we have some H minus left over, or excuse me, Cl minus left over. And now our alcohol is going to attack. So it's going to attack the carbonyl carbon, kick up these electrons. So we have an OH over here. And we now added OH plus our R group. And at this point we have a plus. What can we do about that positive sign? What do you guys think? What can we do at this point to get rid of the plus charge? Yes, so we have Cl minus that will come in and deprotonate. So it will take that hydrogen, give those electrons back. And so now we have a happy molecule like so. Do you guys think the reaction is done? And I'm sorry, this is too ugly. I have to fix it. To give you guys a hint, I will name this for you. This is a hemi-ketol. So do you guys think the reaction is done? No, because it's the ketol reaction, but we got a hemi-ketol so far. So in this case, we're actually going to have another mole of our ketone react. So, excuse me, not another mole of our ketone, another mole of our alcohol is going to react. And we remade HCl, right? So at this point, we are going to have our HCl come in and be deprotonated again. And the reason this happens is to make the OH a better leaving group. So now we have H2O, and it has a plus charge. And on the other side, we have our OR group. And at this point, the second mole of our alcohol can attack the carbonyl carbon, kick off the H2O, and now we get OR and OR. And so at this point, we have our ketol. And before you guys panic or ask, no, you do not have to know this entire reaction mechanism. So all you have to know is that in an acid catalyst, you will go all the way to a ketol. If you have no catalyst or a base catalyst, you will stop at the hemi-ketol. I know this was kind of a long mechanism. Do you guys have any questions? Yes, I can definitely repeat that. So in an acid catalyst, you will go all the way to the ketol. If you have a base catalyst or no catalyst at all, you will just stop at the hemi-ketol. Also, we could do the same exact reaction with an aldehyde, and you would get in the first step a hemiacetal, and in the final step, you would get an acetal. So again, the same exact reaction could happen with an aldehyde, and you would get a hemiacetal. Excuse me. A hemiacetal, and then the final product will be an acetal. Sort of kind of makes sense. Also, I feel like since I can't see how you guys are reacting to it, I feel like I've lost you guys with the reaction mechanism, and I really hope that's not the case. And then someone asked, would the same rule apply with the acid catalyst and the base catalyst? Yes, it would. So the same exact rule applies here. So with an acid catalyst, you go all the way to the acetal. If you had a base or no catalyst, you would stop at the hemi. Alrighty, so do you guys want me to continue for the next reaction like this, where I draw out the whole thing, or do you guys just want like the summary without the entire mechanism? Because I know we're kind of close to the exam, and I really like going over the mechanism, but if you guys are confused by that, let me know and we can just go over the summary. Okay, so one person said the mechanism is good for me, so we'll just continue like that, unless you guys have any objections. So far, we have done the gem-diol reaction, which I will remind you guys is just a ketone plus H2O and acid or base. And it gives you this thing. The acetal ketol is this reaction. With acid, it goes to the final product. With base, it goes to the intermediate. And then someone asked, what would the base catalyze reaction look like? So let's go back down here. So let's say we had an alcohol and like NaOH. In the first step, we are going to steal this hydrogen. So we would get the alkoxide ion. And now the alkoxide will go and bam, attack, kick those electrons up. So we get O minus, and we add our OR group. And now at this point in the reaction, we have H2O, which we just made. And we have a negative charge. So the negative charge is going to go ahead and protonate using the H2O. And I'm sorry for running out of space, so I'm just going to do the arrow like that. So we get OH plus our OR group. And now in the solution, all we have left is OH. So we can no longer do this next step to like kind of do a second reaction, because there's no way to make this OH a good leaving group. because we just have our base in catalyst, based as a catalyst. So our next step will not happen, and we will stop at the hemi acetal. Make sense? Okay, cool. So I can zoom out a little bit, and I'll leave that up for a couple seconds. And the next reaction is the Amine Formation. So I will go ahead and make another page. So this is where we get fun names for things. So Amine reaction is still going to start with a ketone. And we're still going to do acid and base catalyst for this one. Does anyone have any idea what our reagent will be?